Hi everyone, for today's lesson we are going to begin Unit 2, Rigid Transformations. For this lesson you will need to have the following materials. You'll need a glue stick or scotch tape, some scissors, you'll need some highlighters, something to write with, and you will need to print out the Unit 2 Day 1 cutouts and cut out all of these materials. These two pieces, the blank box and the terms, they will go together and they will be the first thing that we will be using today. All right, canned statements for today is for you to be able to say, I can translate a figure on a coordinate plane. I can label the image and pre-image properly. And I can write a rule for translating a figure. So some key words here is this word translate. Translate is something that we are doing right now. You're listening to what I'm saying, and a lot of you are translating what I'm saying into your native language. It's like a change, is like a translation from one to another, from one language to another, from one location to another. Image and pre-image are going to be words that we are going to be focusing on. Pre meaning before, and then image being what comes after. And then I can write a rule. There will be a special way where we will write coordinate rules for translating a figure. So our unit is called Rigid Transformations. So before I get into today's topic, which is called translations, I want to talk about rigid transformations first. There are 3 types of rigid transformations. Those 3 types of rigid transformations are, first, translations, which is what today's topic is all about. Translations is another way of saying slide, or shift, to move something to the left, right, up, or down. The second one, which we will be talking about in our next lesson, is called reflection. Reflections is where you flip a figure. And the third type that we'll be talking about after reflections is called rotations. And rotations is where you take a figure and you turn it. So we have slide or shift, flip, and turn are translations, reflections, rotations. So before we break apart what a rigid transformation is, let's go ahead and define what a transformation is. And a transformation is simply where you move or change a figure in some way. To produce a new figure. This figure is called an image. So a transformation is where you move or change a figure in some way to produce or create a new figure that is called an image. So a new figure called an image is what happens after you have transformed something. This is something that I need you to know. This term is something that is a term that we will be working with a lot. Speaking of terms, if you wouldn't mind taking out the terms box and the blank rectangle, we're going to create the same type of cutout as what we've done in the past. And I would like you guys to please go ahead and paste our terms box into the center of this rectangle to the very best of your ability. Next, I would like you to please go ahead and cut all the way to the line. So that we have some tabs. The first word that we have is rigid transformation. And a rigid transformation is when a figure changes position or orientation. Orientation means that a figure starts off being in one direction and then it flips, or it rotates, or it has been flipped upside down. That is orientation, where the versus position, where it's just shifting. So it changes position or orientation, but the size and the shape stays the same. That is something I need you to know. Rigid transformations are just where you're taking the same shape, keeping the size the same. Everything stays the same. It's just where it's located is going to be different. In a pre-image is the original figure, and an image is a new figure that is created after a transformation. So, for example, let's say that we are talking about the letter P, a point P, and we're going to move that point up here. In some way, we're going to move it. And now it is going to be called P prime. This is a transformation. It started off being in one position, and then it changed to another position. The notation that we are going to be using whenever we are working with a rigid transformation is we're going to be calling the pre-image like a point with no parenthesis, or no apostrophe. Versus an image is what comes second. It will have an apostrophe. An apostrophe means that it comes second. A pre-image came first. Please also note that in a rigid transformation, I'm going to draw two triangles. The shape and size will stay the same, which means that the angles and side lengths will remain the same. So I'm going to write that the angles and side lengths will remain congruent. And all I'm doing is putting in some tick marks just to emphasize the fact that everything remains constant. Nothing is going to change. So I want to write down that the this example up here, we have triangle ABC would be considered the pre-image, and triangle A prime, B prime, and C prime would be considered the image. So whenever you are labeling, you put an apostrophe after every single point that has been transformed based on whatever situation or rule that we are talking about. The thing that you need to know is that the angle measures will be preserved. The side lengths will be preserved. It's just where it's located has changed. All right, when you are ready, go ahead and fold these tabs in and go ahead and label the outsides. The first term we had was rigid transformation. The second word we had was pre-image. And the third term that we had was image. When you are ready, go ahead and paste this into your notebook. And then I am going to flip the page to start talking about our first transformation, which is translation. So this is day 1, unit 2, day 1, called translation. And a translation, once again, is where you slide. It's where you're taking one image and you're sliding it to another location. You're shifting it to the left or down, or maybe you're going right and up. It is a slide. A translation is just like I had mentioned, it's a slide. It's where you slide or shift every point in the figure the same distance in the same direction. Keywords here being that you are sliding or shifting every single point in the figure the same distance in the same direction. So we are shifting everything in the same distance, in the same direction each time, depending on what rule we are given. That shift is going to be left or right, up or down, depending on what our rule says. So if you wouldn't mind taking out this coordinate notation for a translation, we are going to talk about this. Let's go ahead and paste it directly into our notebook. Now, when I say that we're shifting left or right, up or down, that depends on if we are talking about X, a change in X, or if we're talking about a change in Y. Left and right on our axes, that is our X axis. So left or right, that deals with our change in X. Up or down, that deals with our change in Y. So it depends on what we are talking about. If we are referring to X, then that means that we will be going to the left or we will be going to the right. If we're talking about y, then that means that we will be going up or we will be going down, depending on if you see a plus sign or a minus sign. Left means to the left or minus. Right means plus. Up means plus. Down means minus. So, the coordinate notation for a translation. You can describe a translation by the following notation. XY changes into, so this arrow means the language, changes into X plus A and Y plus B. This whole piece where you have a coordinate of X, Y, an arrow, meaning changes into, and X plus A and Y plus B, that whole thing represents a rule or a coordinate rule. This whole thing is called a translation rule or a coordinate rule. It's called a rule. It's a rule telling somebody what to do or telling you what to do in terms of the figure. So you can describe a translation by the notation of X, Y, or your ordered pairs change into X plus A and Y plus B. This shows that each point X, Y of figure 1 is translated to the right A units and to and up B units. So if figure 1 is our image and figure 2 is our pre-image, this one came first, this one came second, you have to ask yourself, how do you go from this point to this point? How did it shift? And because there is a plus sign indicates that we are going to be shifting to the right. And a plus sign for the y-axis means that we are going to be shifting up. So it's going to be all about counting. If you saw a rule that said XY changes into X minus A and Y minus B, this means left and down. So in a nutshell is if you see the word right, that means that you'll see a plus sign next to the X. If you see left, that means that you'll have a minus sign near the X. So this is all dealing with X. And if we're talking about Y, that's going to be down. Up, excuse me. We'll start with up. Up means plus, down means minus, and this is all your Y axes. So X is left and right, and Y is up and down. What you're going to see is an example, or many examples like the following. So here are a couple examples that we will have in our notes for today. Our first example is write a rule for right 3 units and down 4 units. So if I asked you to write a rule to represent going to the right 3 units and down 4 units, it would look like this. You would write your ordered pair of X, Y. You would draw an arrow because it means changes into. And to go to the right means that your X values will be increased by 3 units, comma. Down 4 units means that your Y values will be decreased by 4 for each time. And that is your rule. The next example. How would the rule change if you started at figure 2 and moved to figure 1, so what I'm referring to in this example is up here in this picture. What would happen if we started at figure 2 and ended at figure 1? Well, you would have to pick a point. So I would pick this point right here on the edge. And I would ask myself, what am I doing in order to get to its corresponding or matching point on the other side? Well, it appears as if I am going to the left so many units, and it looks like we're talking about A. We would be going to the left A units and down B units. So we would be going to the left A units and then going down B units. And I got A and B based on the rule right here. It would be going backwards. So that's what I'm going to say. We would say that it would be XY changes into, so our coordinate, x comma y, changes into x minus a, comma, y minus b. Some problems that you might see in your homework as well as on any quiz or test might be something like this. Use the rule xy changes into x plus 3, comma, y minus 4. For letter A, it's going to ask you, what is the image of W being located at 2, 5. So what you would do is you would say that W 2, 5 changes into W prime. And W prime is where you take your x value, which is 2, and you add 3 to it. And then you take your y value, which is 5, and you subtract 4. So that means that W prime becomes 5, comma, 1. And that is your answer. You might see a question that will ask, what is the pre-image of R prime being located at -1, 7 using this rule? So think about what image means versus what pre-image means. Image means that you have your starting point, you use your rule, you come up with where you land. But pre-image means after you did all of this, you landed at -1, 7. Where is R located? Whenever you see this language of what is the pre-image, what I would like you to please do is do the reverse of the rule using opposite signs. So change the rule and use opposite signs. So changing the rule to use opposite signs looks like this. If the rule is xy changes into x plus 3 and y minus 4, to find out what happened before then, what you're going to do is you're going to change the rule to xy changes into, instead of x plus 3, it'll be x minus 3. And instead of x minus 4, or sorry, y minus 4, it'll be y plus 4. And we're using the reverse because we want to figure out how did we go from r to r prime if we only know what r prime is. So we kind of have to do this problem backwards. So if r prime is located at negative 1, 7, then that means that it goes back to being r using the opposite rule. So I'm going to go negative 1 minus 3, and I'm going to go 7 plus 4. And when I do that, I land at r being located at negative 4, 11. Let's check this out. Is negative 4 plus 3 negative 1? Yes. Is 11 minus 4 7? Yes. So by using the opposite signs for our rule, we are able to find the image. You can always tell what the image versus pre-image is based on that apostrophe. And that is the end of today's lesson. If you have any questions over anything that I talked about today, please feel free to email me. Otherwise, I hope you have a wonderful day.